Hello everyone. So in today's tutorial, we are using k-means to extract a dominant color. Also, we are visualizing the value that we get from k-means. So in this tutorial, later on, you will see a 3D graph having various clusters of different colors you have in your image. And today in this tutorial we are using this image here you can see to extract the dominant color. And before we start today's tutorial, I want you to have a look at what k-means is. So just have a look at this image here. So what k-means does is, is basically, suppose you have suppose you have an image in which you have three colors mainly, the blue one, the red one, and the green shade you have suppose in your image. So k-mean basically divide the color into clusters, and then it will make a partition between these clusters, and then count the value of pixel that in the cluster. So and also simply it returns the cluster which is having maximum frequency of values. It will return it as a dominant color. So hope you gain a bit knowledge about what k-means is and how it is working at backend. Now let's have a look at our coding section. So to plot graphs and to plot 3D axis, you have to import these two libraries. First one is matlab and the second one is mpl toolkits underscore toolkits. Then to access the image, you have to use CV2 library and NumPy for NumPy. You can use later in this code for basically manipulate for creating arrays and manipulate them. And also you have to mention this statement before running your code, that is %matplotlib underscore space in name. So let's start our coding part today. So here we have, first you have to import these libraries. So make sure you install it in your system and import them. And then let's come. So first we will access the image that we have. So to access it, we use cv2.imd. Then you will read this image. Make sure you convert it to RGB value. So the image you access, it is in BGR format, so you have to convert it into RGB. For those who don't know what BGR and RGB is, it's basically a color format. So BGR stands for blue, green, red, and RGB stands for red, green, blue. So make sure that you have a image with we save the image in RGB format, that is red, green, and blue. So using matplotlib, that is plt.imshow, here I am showing you the image. So this is our image for today. And using this part of the code, we are basically splitting our image into red, green, and blue section, and we are simply plotting this into using Access3D. We are printing our clusters here. So as you can see through this image, we have various clusters of different pixel value of RGB. As we have RGB we have three values R and G and red, green, and blue. So for each axis, we have a particular color, and here is a grayscale graph. So as you can see here, we have a graph, and now we will access the dominant color or the dominant colors that we have in this image, and then we will plot this graph again. So for accessing the dominant color, here we have the function. So it's simple. All you have to do is just import k-means as we imported above from sklearn. You have to import it. So here we have using sklearn, we already import our k-means. So here you can see we have sklearn.cluster import k-means. So you have to import it also. Then we just made a class for dominant color and we assigned it, and later on you will know what these values are. So for now, just have a look at this. We have a function in this class. As first one is a dominant color, the second one is for RGB to hex value. Then we have plot clusters. This basically plot the clusters of different colors we have in our image, and this one is for plotting the histogram. So let's go them one by one. So our code starts from this. So here we define 5 clusters. We want 5 clusters from our image, and then we will create an object for our class, that is of dominant color class, and here we pass these two parameters, image and clusters. So when we assign this object, here you can see we have a constructor and it will assign clusters and image with the image and cluster we pass, and then we will call our function, that is dominant color. So let's have a look at the dominant color function. So here you can see we have a dominant color function. Now we assign this image here to this variable here. We will print the image of our shape of our image, and then we will reshape our image. And here we have a image 3D, and we reshape it to 2D as we need only the pixel value. We are not interested in the coordinates of the pixels. We have to extract the dominant color, and for that we will change it to a 2D array. So we will multiply the first and the second parameter. So as you can see here, we print these values. So first we have a 3D array of 100 cross 100 cross 3, and then after multiplying we will get an array of 10,000 cross 3. So now we have a 10,000 cross 3 array, and each value in the array is RGB value. Now we will set the set a k-mean algorithm, and we will assign n cluster parameter inside it to 5. So here we mention 5 below, 5 cluster, and we passed it already. And here self dot cluster is assigned to 5. So here we are passing self dot cluster, and now we will fit our model on the particular image. And here after this statement, our model is successfully fitted. Now we will extract the information from our model. So the first information is colors, and the second one is label. So color is basically, as we pass 5 clusters, so it contains 5 RGB pixel values, and this label contains 5 different types of label. So it basically for each pixel we have the number of counts of pixel, which are basically in labels variable. So let's have a look at what these labels are doing here. So basically label contain the, let's have a look at this image. It will be a bit easier for you to understand. So let's look at this. So suppose you have this as an image. So label basically contain the value. Suppose you have 3 colors here, red, blue and green. So label contain the value of each point here you have in this image for this cluster. So in the label you have 5 values, and each value contains the frequency of a particular cluster. So label the k-means return us the value of each cluster that we have. So for red it has a particular number of counts, for blue also and for green also. So in this label variable here we have a count of each particular pixel. So hope you are now you know what these colors and labels are, and to get them you just have to assign dot cluster underscore center underscore, and for labels you have to assign k-means dot labels underscore. So now we have labels and colors, and what we will do next, we will just simply plot our graph. So here is a graph. So as you can see, we define 5 clusters here. So we have 5 clusters. That this one is light green. This is also a green shade. Then we have a dark red shade, and this is a brownish shade, and then we have light yellow shade. So this is our image. As you can see, these are the values that are plotted in this graph. And to plot this, we use this function here, that is plot cluster, and we use this package, that is access3d. This package we import above. Here you can see we have this access3d from MPL toolkit, and then we will pass these label counts, and we just plot our graph, and here we assign the each pixel value RGB values here. And also we use the RGB2 heads as the color to pass in this scatter function, we have a color parameter and it needs the hex value. So we convert our RGB value to hex value, and here is a function for that particular function, for that particular value to be changed from RGB to hex. So we use this function above. So using this, we will plot our graph. So here you can see we have a graph of 5 different clusters. Then we will pass this DC object to plot histogram, to plot a histogram. So here you can see we have a histogram, and also in this histogram, what we will do, we will assign the cluster in a descending format. So the one which is having maximum value will come in first, and the one which is having least value will become at last. So here you can see the light yellow shade is having maximum value, so it is in front, and then it is in decreasing order. So this is and to plot this histogram, you have to use this function here. So let's have a look at this function. So we first make a array here using np numpy, assign it to 0. Then we will count the values that we have in label. So for each particular RGB pixel, we have a particular count, and that we stored in our label. So here we count it using this code, and then we append the frequency of cluster centers here using this code here. And then we will, as I told you, we have a descending order in our histogram. So we will, using this, we will descend our code, and then we will assign particular values, and then we will we have a red, green, and blue values. So using this code, we will basically print here from this. We will basically access these values, and then using display chart, we will display the histogram that we have. So here is our histogram, and as you can see, we are getting light yellow, and this is our image. So light yellowish shade that we have in our image is a dominant color. So it is in front. Then we have a brownish shade. There are k-means showing that it is of dominant color. It is the second dominant color. Then the greenish part is our third dominant color. That is just that is just adjacent to our brownish part. And then we have third one is the dark red, and the fourth one is our dark red, and the fifth one is our light green shade. So hope you learn how to plot these graphs and visualize k-means using graph, and hope you learn what k-means is. This is all in this tutorial, guys. Thank you.